Indiana University East School of Natural Science and Mathematics. Examples of gas law calculations. So here we're going to use Boyle's law example where we are given the initial pressure. So this is my P1, initial volume, so V1, and I'm given also the final volume V2, and after the compression we're looking for P2. We know that Boyle's law states that P1 V1 equals to P2 V2. Okay. So rearranging, I have P2 is equal to P1 times, I do this by dividing both sides by dividing both sides by V2, so I have V1 over V2 here. Now if you look at this, one thing to realize is that for pressure and volume, as long as I have the same units on both sides, I do not need to use any specific unit. I can use whatever units I want. So here I'm going to leave the units as is. P1 is 721 millimeters of mercury. V1 is 5.3 milliliters, and V2 is 2.3 milliliters. And if I go through this, I find, and I note that my P2 must have the same units as P1 because of how the units cancel out. The answer is 1.7 times 10 to the 3 millimeters of mercury. For Charles' law, we have V1 over T1 is equal to V2 over T2. One thing to note though is that with Charles' law, temperature must be expressed in kelvins. So let's see the final volume. So let's see, I have my initial volume V1 here, and this is my T1. My T1 is going to be convert 20.85 plus 273.15, converting it into kelvins. So this is 294.00 kelvins. And this is my T2, and I'm looking for V2. T2, similar to here, I add 100 to 273.15, so that's 373.15 kelvins. Therefore, if I'm looking for V2, I'll make V2 my subject, and so V2 is V1 times, if I multiply through by T2 here, I have T2 over T1. My V1 is 2.00 liters. My T2 here is 373.15 kelvins. My T1 here is 294.00 kelvins. And that comes out to 2.54 liters. Again, as I recap, I don't care what your units for volume and pressure are for these problems, but your temperature must be expressed in kelvins.